take an example. Let's say Ahmed Saigal wants to start something new at the canteen. So now there are over 1,000 people on campus. Now he wants to start something new, but he's not sure because there's some level of investment involved in it, and he does not want to take a risk by just starting and it doesn't work out. He wants to do a survey. So what can he do? He's going to basically, let's say he starts a questionnaire, and he wants feedback from all of us, from the students, from the domestic staff, from the admin, from the teachers, so that then he'll be in a better position to know whether he should start his that new thing or not at the canteen, right? Okay. Now the problem is this: people at Cedar at one given time in the building are over 800 to 900 people, let's say, and obviously by all practical purposes, it is not practically feasible for him to take the data from every single individual on campus. That would require a huge manpower, that would require cost, that would have time, that would require a lot of time. So considering cost, manpower, time constraints, he will not be able to do that. So what he will not be able to do is do a survey on the entire population of Cedar. Now I'm using the word population here. Population word in stats doesn't mean the number of people living in a country. It doesn't only mean that. When I say the term population in stats, it means the entirety of your study. Every single member within your study becomes a population. So right now, for Ahmed, it would be like if everybody at Cedar is part of the population for him, because they're all his potential customers for that campaign. Now, because of cost and time and manpower constraints, he will not be able to survey or get the information from every single person on campus. So what he will end up doing is that he will not survey the entire population. What he will end up doing is what is called sampling. He will end up selecting a subset from the entire population to take the data from. Now that subset that he's going to choose, or however he's going to take that subset is called a sample, and it's a subset of the entire population. Now, I'm sure we all agree it's very reasonable to say that if he could have surveyed the entire population, that would have been best. Because he would have gotten the feedback from every single person on campus, and then he would have made the best decision. We all agree on that. But then most of the time, statisticians are not able to do a survey of the entire population. By the way, surveying the entire population is called a census. C-E-N-S-U-S, it's right there. Census is the name given to a survey. It examines every member of the population. It has its advantages. A true representative with completeness, of course, because you're not leaving out anybody. Disadvantage here suffers manpower, time, and resource constraints. We just spoke about that. That's very reasonable. Okay, so let's say he is unable to do that. So now what he's going to do is he's going to select a lot from the total population. Now that lot will be a sample for him. Now there are various ways of selecting that lot. See, statisticians don't want to select a lot just like that by just handpicking or by, because see, when you're selecting a lot from the entire population, you can introduce bias in your selection. Let's say he only contacts those people who he knows personally on campus. Only those students in ASP he knows personally, only those A2s who he knows personally, only those teachers who he is in good terms with, right? So that would not be what statisticians call a random sample. That would be a biased sample. And any information coming from a biased sample cannot be taken for any critical decision. So what he needs to do as a statistician, if he's a statistician, what he needs to do is, he needs to follows certain procedures in order to sample and get an unbiased sample, which we call a random sample. He needs to get a random sample. Is anyone with me till here? Okay. Now, the word random, I've spoken during S1 as well, if you remember last year. Random, basically, is a word that comes in statistics when we talk about probabilities, when things are chance-based. So when we say a random sample, we are trying to say a small lot taken from the entire population, but not with a biased perspective, but with a certain procedure that allows every single member of the population an equal chance of being selected for that sample. See, I'll just come back to the story, but just to explain you what a random and a biased sample would be. It would be like saying, if I want to just like maybe take a view on something from this class, so maybe I just don't want to get up and go at the back and I'll just ask this 5-6 people sitting in front. Now that would be a biased sample. Because I'm not giving an equal chance to every single person in the class to be selected to voice their opinion. Right? So a random sample would be that I select a certain procedure where every single person gets an equal chance of being selected. But select to थोड़े से लोग होंगे, that's fine. Like maybe I just want like to get to know from like 7-8 people. But I'm not giving a chance to the backbenchers to say something. That's wrong. That would be a biased sample. As a statistician, I cannot do that. And then I cannot rely on that information. Right? That information will also be biased then. So then what I need to do is I need to select, follow certain procedures to make sure that my sample is random and unbiased. Now there are various methods of selecting a sample depending on what situation you're dealing with. Now, I'll just give you a few examples. Like, let's say I was selecting 7-8 people from this, let's say 10 people from this class. So what I would do is, I would, maybe if I have a random number generating software, so I would put all your, like maybe I'll just like all these seed numbers, like A1, A2, A3, but so maybe if I would just like count like 1, 2, 3, 4, 5, so I would allocate a number to each of you till the end. So maybe the number is like, let's say there are 50 students here, so the last one will get a number 50. So my number goes from like 1 to 50. Then I would put those numbers in the automatic, that's random generation software, and the software will throw out 10 random numbers. And whatever those 10 numbers are, I'm going to select those 10 people. So, see, everyone got a chance of being selected. So, I did not introduce any bias. It was randomly, those 10 numbers were randomly generated by the software. By the way, it's not just the software, there are also random number tables. I'll show you a random number table. A small portion of the random number table. This is a small portion of a random number table. Some math books have random number tables at the end of the book as well. And see, I can use this to maybe select like 5-6 numbers from this. So there is no pattern. There is absolutely no pattern to these numbers. They are totally random. So if you just go on selecting numbers, the numbers are going to be purely random. You just can't introduce any bias because back in the numbers themselves have the pattern. The layout of the numbers have no pattern. So it's this or maybe a software that generates numbers, whatever. My point is, I would end up giving every single person an equal chance of being selected. So Emma needs to do something like that. So now what can he do? Maybe he can take every single student's roll number, registration number, and then put it in the software and generate maybe. Then he would have to think, okay, so how many people should I choose from the AS, how many people should I choose from the A2s, how many from the teachers. Now, do you think they all should be equal numbers? No, they can't be, because there are more students and less teachers, very less teachers, but more than the teachers are the admin, and more than the admin are the students, and then the A2s are less and the AS are more. The point is that there is a fluctuating number. So there has to be some kind of a ratio, some kind of percentage that one can say, okay fine, so from the AS I'll select like maybe 100 people, from the A2s I'll select like 70, teachers may say I'll select 10, admin may say I'll select like 25, something like, I'm just giving an example. Something like that. So he'll set something on the basis of whatever, however he thinks. And because he's in a better position to know what's the potential market, so he's going to set a number.
Wouldn't it be simpler to see how many people go to canteen? And
that's what I'm saying, because he's in a position to know how many people go. So according to that, he'll set a number. So do many teachers take it? Do students go more? Do the admin go more? So according to that, he'll set it up. My point is that he has to set up some number and then select the lot. Once that is done, now how he selects the lot, there are various procedures for that. We can take registration numbers and do that simple, it's called simple random sampling. There's number generation. It's like putting everybody's names in a box and picking 5 numbers out, 5 checks out. That's also simple random sampling. That's another example of simple random sampling. And even number generation is another example of simple random sampling. So there's a simple random sampling method. Then there are many methods. There is systematic sampling, there's stratified sampling, there's multi-state sampling. All these samplings will be depending on what's the extent of your research. Like I'll give you an example. When light bulbs are tested, let's say the Philips factory is making bulbs. Now, do you think all bulbs go to the market without being tested? There are certain bulbs that are being tested. Now, let's say they have thought of a number, okay, we will test 5% of the bulbs, whatever. So, if there are 100 bulbs coming out, they'll select maybe 5 from the 100. Or let's say they're going to select 10 from the 100. Okay, so every 100 ka jo batch aata hai, they want to select 10 out of those and want to test them. So now let's say there's a conveyor belt and all the bulbs are being manufactured from in the machines and they're running out of the machine on a conveyor belt and the testers are standing. So there, because all bulbs are identical, so how would you pick up the bulbs? Now what they would want to employ is a method called systematic sampling. They might want to do this. Let's pick every 10th bulb that comes out of the conveyor belt. Now they haven't introduced any bias. Introducing bias would be, okay, select this one, no, don't select this one, okay, select this one. Now, whatever, even if the bulbs are identical, still you are introducing maybe some bias. But here if I say every 10th bulb that comes out of the conveyor belt, I'm going to select one after every 10, so out of 100 I'll end up selecting 10. And I have about 10 bulbs to select to test. So this is the kind of sampling which is called systematic sampling. I'll just give you an example that there are various methods of sampling. But the ones that we are right now concerned with is simple random sampling. So then there are various methods and then you can read up on that. Okay. So the point is that we need to do sampling. And the point is Ahmed needs to do sampling. So he will select the lot. Let's say 100 from the AS people, 80 from the A2s, and he's done his sampling. He's done a sampling, let's say he's even selected the lot. Now that one stage of sampling is done. Okay? Now he'll be collecting the data, and then once he's collected the data from there, then he may take an average or he present it on a chart and he's going to analyze the data and then he's going to come up with a distribution. Are we good? Okay. Now I just give you an example of every 10th bulb being picked from the conveyor belt. Achha. Do you agree that the bigger the sample, the better representation it would be? It's like saying, would Ahmed be okay with the fact that there are 800 students here and he wants to start something new and he asks only 20 people? It doesn't even make sense. He would want to ask as many people possible, because the bigger the sample, the better representation it would be of the entire population. What is your sample? What's the ideal sample? The ideal sample is that your sample is the representation of the entire population. That's why we don't want the sample to be biased. We want the sample to be purely random so that it can be a good representation of the entire, because that's the best we can do. We can't survey the entire population. I wish we could. But that's the best we can do. But us best ke andar bhi, how can I make it better? By having the sample as large as possible and by making sure that no bias has been introduced in selection of the sample. Right? and it's done purely randomly. Are we good till here? Okay. Now we all agree that a bigger sample has its advantages, right? A bigger sample has its advantages, but sometimes in some situations there is a disadvantage to a bigger sample also. Let's take the example of the airbags that are tested in a car. Do you know they actually smash the car in the wall to test the airbag? Now the car it's gone. The car cannot be repaired. So there's a total loss. So now if the company is producing 2,000 cars, let's just take an example. You don't want to do the test on like 500 cars. So in that case they need to have a small sample. But not so small, there is not a good representation. So there is a trade-off. So I'm just trying to make you realize that it's not always about a larger sample, although a larger sample is always the best representation, but sometimes there are situations where you cannot have a large sample. So you have to make do with a small sample as well. Some situations. Are we all good till here? Any questions? Okay. So I have just talked about all this. The complete set of objects interest investigation is known as a population. We'll just give some examples of a population. You have that with you. A representative subset of population is called a sample. We just discussed what the census is. It's a survey done on the entire population. It has its advantages, it has its disadvantages. Now what's a bias? The tendency for pattern of errors to influence data in an unrepresentative way is called bias. That's the formal definition of a bias. But you understand what I mean when I am introducing bias in a sample. You understand that? So there are many kinds of biases that you can introduce. You can introduce selection bias, structured wording bias. Structured wording bias normally आता है questionnaires वगैरह के अंदर. Interviewers bias आ जाता है. Interviewers ask leading questions, kind of answers they want to get, or the selection of questions they make. Recording bias आ जाता है. Sometimes you just don't want to record certain data. You just select a data to be recorded. You feel that this data is irrelevant. So sometimes you introduce, the recorder introduces his own bias. So there are many ways of introducing bias into the data. So we need to be conscious of the fact that we need to keep ourselves away from this bias so that the sample that we get at the end would be a good representation of the population. Whatever result the sample gives us, we can take a critical decision on that sample. And this is exactly what companies do. Do you think companies invest millions of dollars into a project by just like on their whim? They do surveys, they take data, they do their analysis, and then they take their decisions. So they have to make sure that the information that is coming in has to be very unbiased, has to be completely unbiased, has to be random, selection has to be random, information has to be unbiased, so that they can take a critical decision on it. Alright. So a random sample is one that ensures that every member of the population has an equal chance of being selected as part of the sample. So we are all clear on that. A sample is said to be good if it's random and as large as possible, and we understand why we're looking at a large sample. That's pretty understandable. Types of random sampling, I just spoke about simple random sampling, I spoke about systematic sampling. There's a stratified sampling as well. Stratified sampling normally comes when the population has some kind of, you can divide the population into, or you can say the word is stratification. You can stratify the entire population by virtue of some quality they have, maybe on the basis of education, maybe on the basis of wealth. Normally, stratified sampling comes in when you bring it on a large population, like maybe on an entire city or an entire area or country or whatever. Then stratified sampling will be, because there are many factors that need to be taken into consideration. Okay, simple random sampling we spoke about. Remember I spoke about putting the chicks, everyone's names into a box and then picking out 10 names. That's drawing lots. And then random number sampling was the one that I said, let's generate 10 random numbers using a software, or maybe generate 10 random numbers using a random number table. Right? That would be the random number sampling. But it's all part of simple random sampling. Are we all good till here? Any questions? Okay, so let's try this out. Now there's a portion of the random number table already given to you. Now, using to select a random sample of 8 people from a group of 100. Now, there are 100 people. I just need to select 8 people. Now, how am I going to use this? What I'm going to do is I'm going to associate a number to each person. So, if I'm going to allocate numbers to 100 people, I might want to do 00 till 99. That covers 100 people. 00 to 99, 2 digits. Right? The lesser the number of digits, the better. Now, I am going to select 8 2-digit numbers from this table. Now, you can go any way you like, whichever way you go, it doesn't matter. You are not introducing any bias in it because the number, there is no pattern in the numbers. So, whether you go left to right, top to bottom, right to left, whichever way you want to go, you can start. Let's say just go the regular way, left to right. So these are the 8 people I will select. I'll select the person 68, whoever that 68 number person is. I'll select 72, 53, 81, 59, 25, 34. One more? 70. 8 people. Now it was totally random. I did not introduce any of my bias. I didn't even know the numbers aage kya aayenge. I just went on. I just went on and on. Whatever the numbers were coming out, I just started calling out the names and select those people. This is one way. If you want to start left to right, see, whichever way you start doesn't matter. It's going to be a random number generation. So whether you just want to go left to right, right to left, whatever, just go with that. Now next part B is 8 people from group 60. So I'm selecting from group 60, that means I need to go from 00 to 59. Right? So I'll just go on selecting the same way. Any number that goes beyond 59, I'm just going to disregard the number and select the next one. That's it. And I just go on selecting. So when I'll be doing for part B, I'll say, okay, so 68 no, 72 no, 53 yes.
Can you say 25 is it? 25 is it?
25 would be in. 81 no, 59 yes. 25 yes. 34 yes. 70 no. 54 yes. No, not 95. 32. 1, 2, 3, 4, 5, 6.
So 32 with 23 will accept that.
Right to left चले जाओ, but then decide on one pattern.
अच्छा.
Don't change, because if you're going to change in the middle, that means you're introducing your own bias.
मतलब ज़्यादा repeat हो जाएगी ना.
नहीं, repeat नहीं. In the middle, if you want to change your pattern, which means that maybe there was some kind of a number that clicked to you and you don't want that number, maybe you change it. So you are introducing your own bias. See, I'm just going left to right.
Okay.
Whichever number comes, I'm not introducing any bias. You want to start right to left, you go right to left.
Wouldn't it influence the data that much? By any...
I know, but then again, maybe you have some favorite numbers you don't want to select.
Okay.
Maybe you already know the number of certain person, he didn't want to select it, that's why he changed the pattern number. My point is, there is no need to change. Change would come in if they would give you a certain advantage. If the change is not giving an advantage, why would you want to change a pattern suddenly? So, 32, not 68, not 74, 1.7. 1, 2, 3, 4, 5, 6, 7.
5.
0, 5. I got my 18. So this is just an example. I just took a small portion from a random number table, and this is just an example.